Let's recap. What's our goal in Chapter 16? We want to estimate mu by providing a range of values that we think mu lies within. We start with our sample mean. We know that our sample mean is not going to be exactly equal to mu. It's not likely. So we give ourselves some flexibility, some leeway. And we call that flexibility the margin of error. So the margin of error is equal to z, or we call this a z star, is a critical value, just a fancy name for a z-score. Z star times the size of one standard deviation. So that is how we calculate the margin of error. So the formula is the sample mean plus and minus the margin of error. Let's repeat that. A z star, we call this a critical value. It's just a fancy name for a z-score. What does it tell us? It tells us the number of standard deviations we expect our sample mean is from mu. So as a researcher, you have the flexibility to choose a z value that you want. Is it 2 or 1.5 or 3 and so on and so forth? And then how big is one standard deviation? That is measured by sigma divided by the square root of n. So the product of z star and our standard deviation tells us how close we expect our sample mean is from mu. So let's take a look at a quick example. Let's say we want to construct a 95% confidence interval. Our z star, our critical value, is roughly 2. What does that mean? So this is mu. So the middle area is 95%. We expect our sample mean to be somewhere within the +2 and -2 neighborhood of mu. So as a researcher, you don't have to choose 95. You can choose 80%. Then you will have a different z value. So because we are choosing 95%, so our z star is roughly 2. Okay. So this is 10, our estimate. What's the margin of error? Is z times the standard deviation. So 2 times 1.5 is 3. And this is also 3. So 10 minus 3 is 7. So our 95% confidence interval, sometimes we use CI to represent the confidence interval. In this example, it's going to be 7 is the lower bound, 13 is the upper bound. Then we say mu lies somewhere in this interval. That means mu can be any number between 7 and 13.